I'm not that old, but if you look at my grade 12 math textbook, in the back of the textbook, there was a table that looked like this, and it said theta, and there was a bunch of angles here, and then what do you think was in the next column? Yeah, all the trig ratios. Because we didn't walk around with calculators, on calculators, let alone on your phone or your iPod or all of these things, right? Calculators were just becoming the norm of being used in high school. And I think that, hard to imagine, but the one good thing about having to use a table is you really had a sense of the pattern in the values. I think sometimes you put it in the calculator, you think it's this magic number that comes out. You probably haven't noticed this pattern until now, until the sine ratios, until we actually looked at it visually on a graph. They start at 0, they go up to 1, they go back down, right? If you sit there going the sine of 0 degrees, 1 degree, 2 degrees, they're going to start at 0, they're slowly going to go up until you get to 90, in which they're 1, and then they're going to slowly go back down again. There's no way to avoid noticing that if you're using a table, right? 0 degrees, this is 0. You go up to 90, it goes up to 1. You go back to, you go to, the table wouldn't have 180 in it, but at the very least you know the pattern in between there. Don't think that it's just some magic number. Now, the magic that we have to dispel right now is how the inverse trig ratios work. It's important to understand how the inverse trig ratios work. If you do sine inverse of a positive, we have to look at what it gives you. If you do tan inverse of a positive number, we have to see what it gives you. And if you do cos inverse of a positive number, what's it going to give you? And then we got to look at those three things if you do a negative. And then we will understand. We will have a great sense of knowledge with this that will help you tremendously as you work through things, rather than think it's some magic. Think about what you know about the signs of the trig ratios. What happens for sine here? Sine goes positive, positive, negative, negative, right? This is sine. So let's put the picture right next to what it goes with. Here's my picture for sine, right here. Change the color so we can see it. There's the picture for sine, right? And this can go over here. Why is that? Easier to rewrite it here. Where is sine positive? If you put sine inverse of a positive number, where is it logical that it gives you the answer? If I do sine inverse of 0.5, is it going to give me this angle or this angle? It's going to give you quadrant 1. Okay? All of them are quadrant 1. This gives you quadrant 1. This gives you quadrant 1. This gives you quadrant 1. When you put a positive ratio in, it always gives you an answer in quadrant 1. What if you put a negative number in? For all of them? Well, negative isn't in quadrant 1. Where would negative be? Quadrant 4 is negatives, right? If it gives you an answer of negative 30 degrees, that's over here, right? Why does that make sense? What's true about the sine ratio? It goes plus, plus, minus, minus, right? Where's the closest place to the start where sine is negative? Sine goes plus, plus, minus, minus. It gives you an angle there if it's positive, and where if it's negative? Over there, right? It gives you that. It gives you a quadrant 4 negative angle, right? What would it do for tangent? Where's tangent positive and where is it negative? Tangent's positive there and there, negative there and there. What do you think tangent inverse does when you put in a negative ratio? It doesn't do second quadrant. It could, but it doesn't. If you put in a positive ratio, it goes here. If you put in a negative ratio, it just gives you a negative angle going backwards. Okay? Quadrant 4, negative angle. However, this one is different. This is different. Let's label it as different. It's different. Where does it give you an angle here? Why can't it do the same thing? Let's look at a picture here. Where's cosine positive there? What else?
4.
It's positive there. Why can't it give you an angle in quadrant 4?
Because it's positive.
Because it's positive. Where's the most logical place that it should give you an angle?
2.
It gives you an angle bigger than 90 in quadrant 2. Okay? Quadrant 2, positive angle between 90 and 180. 90 and 180. Does that make sense to you? You have probably used the cosine law before. You might use it in physics. The cosine law is better than the sine law sometimes when you're finding angles because it gives you an answer all the way from 0 to 180. The sine law has an ambiguity in it that it's possible you can have two different answers, this angle or this angle. We don't need to get into that now. You should keep this in mind when you're using your calculator. This is why you probably were taught last year, just don't put in the negative angle when you're using the inverse buttons. Always put in the positive because then you know where the angle ends up being. If you use the negative angle, sometimes you get an angle in quadrant 2, sometimes you get a negative angle in quadrant 4. It doesn't always work the same way. You could teach yourself to use this, but it's simpler to just say, when I'm using these buttons, I'm always going to put in the positive ratio. Okay? I think I've given you more than enough than you need to finish this. You notice that it's asking you for different things here. Finding an angle given a ratio. You should be able to label the picture here. I even gave you the dot to give you an idea of where it should be. If you know the ratio, here's some steps in logic for you. Here's you thinking about them. You know the ratio, right? Ratio is 12 over 13. Here's the next step in your thinking. Ratio involves two sides. Here's the next step in your thinking. Can find third side if you know two sides. From grade 8, right? You know a ratio. You know that that a ratio involves two sides. You know from grade 8 that if you know two sides, you can find this third side. So what is the big jump in logic here? If you know the ratio, okay, I guess we need one more thought here. When you know all three sides, you can write all three ratios, right? You don't need to write all three ratios here, but it might be nice to be able to write all three ratios. If you know the cosine, I have never asked you to write the sine, but I would like you to here, right? You can use Pythagoras to find the missing value, and then you can write the other ratios. You could find the angle and then get the other ratios, but I would like you at some point for this question to write down what sine of theta are and what tangent of theta are, even though I didn't ask you for that here. Using all those steps in logic, you can find the missing side. All right, can we get going here?